Good day, sir. My name is Romel Eplarito, BSME 2A student, and I'll explain my response to the thermodynamics activity you set up. Okay, ideal and actual reheat cycle. First question. A reheat cycle with two stages of reheating is executed with steam expanding initially from 90 bar and 530 degrees Celsius. The two reheater pressures are 10 bar and 0.6 bar, and the steam leaves each reheater at 480 degrees Celsius. Condensation occurs at 0.03 bar. For an ideal cycle, find A for QA and N. Next, B for the engine. Ignore the pressure drop through reheaters. Let the engine operate through the same states. And compute W and N. And next, but not the least, C, what is the steam flow rates for an engine output of 20,000 kilowatts? Okay, my answer for that can be seen in the illustration, which is from 0.3 bar to 90 bar, and there the value in H, S1, H2, H3, H4, H5, H6, H7, VF7, WP7, and HB7 is obtained. Okay, H1 is equal to H at 90 bar and 530 degrees Celsius equal to 3462.45 kilojoules per kilogram. Next, S1 equal to 6.755 kilojoule and kilogram. K equals to S2. In the next row, for H2, H3, H4, and so on, in the same in taking H1 and S1. So next, for QA or heat supply, H1 minus HB7 plus H3 minus H2 plus H5 minus H4, since we already get the value of it by substituting it, the value is 3.62.45 minus 109.862 plus 3544.4 minus 2856.782 plus 3553.5 minus 2775.783 is equal to 4,817.923 kilojoules per kilogram. Okay. Next, for W or work, is equal to H1 minus H2 plus H3 minus H4 plus H5 minus X6. So substituting it, the given will be 3.62.45 minus 2856.782 plus 3544.4 minus 2775.783 plus 3553.5 minus 2783.94, and then calculating it equal to 2143.845. So next, Wn or net cycle work equal to W minus WP, the formula for next cycle work. Is substituting it to be given the data is 2143.845 minus 9.0219 is equal to 2,134.828.231. So next, for n is equal to Wn over Qa. And since the answer is already obtained in the given data, the next move is to substituting it. So n equal to 2134.8231 over 4817.923 is equal to 0.4431 or 44.31 in percentage. Okay. Next, B. H4 equals H at 10 bar and S4 at 7.847 equal to 3540.9. And for H5 equal H at 10 bar and 530 degrees Celsius equal to 3544.4. The formula for that is W equals H1 minus H2 plus H3 minus H4 plus H5 minus H6 by substituting it. The W equals to 3.62.45 minus 2856.782 plus 3544.4 minus 3544.4 plus 3544.4 minus 2783.94 is equal to 1366.128 kilojoules per kilogram. Okay, next, H equals W plus WP over H1 minus HB7 plus H3 minus H2 for the formula of H. And next, substituting it, our given data is 1366.128 plus 9.0219 over 3.62.45 minus 109.862 plus 3544.4 minus 2856.782 by calculating it is equal to 0.3403 or 34.3%. Okay. Next, letter C. Our M equals to 300 over W, that is constant, equal to 3000 over 2143.845 kilogram per kilowatt hour. By calculating it, M is equal to 1.675 kilogram per kilowatt hour. Okay, not last but not the least, steam flow equal to 2000 kilowatt, open close parenthesis, 1.679 kilogram per kilowatt hour. Cancel the kilowatt, the remainder is kilowatt hour. Next will be 33584.518 kilogram per hour times to 1 hour over 2000. Cancel the hour. By calculating it, the answer will be 9.329 kilogram per second. Okay, next question, number 2. In a reheat cycle, steam at 15 MPa, 540 degrees Celsius enters the engine and expands to 1.95 MPa. At this point, the steam is withdrawn and passed through a reheater. It re-enters the engine at 540 degrees Celsius. Expansion now occurs to the condenser pressure at 0.0035 MPa. A. For the ideal cycle, find N. B. A 60,000 kilowatts turbine operates between the same state points expect that the steam enters the reheater at 1.95 MPa and 260 Celsius, departs at 1.8 MPa and 540 degrees Celsius. The steam flows is 147,000 kilogram per hour. Generator efficiency is 96%. For actual engine, Pine NK, MK, EK, and last but not the least, C. Determine the approximate enthalpy of the exhaust steam if the heat loss through the turbine is 2% of the combined work. Okay, also in the previous process, in the same process for it. The formula is the module to get the value of H1, H2, H3, H4, H5, BF, VF5, WPN, HB5, and the illustration that supports it. Okay, let's proceed to N equals WN over QA equals to H1 minus H2 plus H3 minus H4 minus WP over H1 minus HB5 plus H3 minus H2, and then substitute it to get 3.2 minus 2867.734 plus 3557.2 minus 2259.45 minus 15.046 over 3.4 to 3.2 minus 126.791 plus 3557.2 minus 2867.734. Then the next move is to calculate it. And there you will get the answer 0.46116 or 46.12%. Next solution for B. H2 equals H at 1.95 MPa at 260 Celsius equals to 2930.425 kilojoules per kilogram. H3 equals to H at 1.8 MPa at 540 degrees Celsius equals to 3558.7 kilojoules per kilogram. Wn equals to H1 minus H2 plus H3 minus H4 minus Wp. By substituting it, Wn equals to 3423.2 minus 2930.425 plus 3558.7 minus 2259.45 minus 15.046, and calculating it, the answer will be 1776.979 kilojoule per kilogram. Okay, together the MK equals to 147,000 kilogram per hour over 16,000 kilowatts. By calculating it, the answer will be 2.45 kilogram per kilowatt. Next, EC equals to H1 minus H2 plus H3 minus H4. By substituting it, EC equals 3423.2 minus 2930.425 plus 3558.7 minus 2259.45. EC will be 1761.933. Next, getting the answer for WK and CK. WK equals to 3,600 over MK. And since the value of MK is already obtained, the MK equals to 3,600 over 2.45. MK equals to 1469.388. Next, EK equals to WK over EC. By substituting it, EK equals to 1469.388 over 1761.933. By calculating it, EK equals to 0.83396 or 83.4% or 40%. Next, MK equals to WK over W or work. By substituting it, and K equals to 1469.388 over 1853.216. And then by calculating it, NK equals to 0.79288 or 79.83%. And last but not the least, C, exhaust enthalpy equals to H4 plus WK times 0.02. W of H4 is 2259.45 while WK is 1469.388. And by calculating it, exhaust enthalpy equals to 2288.84 kilojoules per kilogram. Okay, next. Last question. Number 3. Steam at 300 bar, 760 degrees Celsius enter the throttle of a reheater engine and expands to 10 bar. At this point, it leaves the engine, enters the reheater, and returns at a bar. 600 degrees Celsius expansion then occurs to the condenser pressure of 0.05 bar. CHF equals to 138 kilojoules per kilogram. On the basis of flow of 1 kilogram steam, find A, WNN of the cycle, B, WN and the ideal engine, and C, in the actual engine the steam enters the reheater at 10 bar, 300 degrees Celsius and later expands to a saturated state at exhaust to the condenser. Find WN and M. So, same process again, showing the illustration, getting the value of H1, H2, H3, H4, H5, VF5, WP, HB5 for use in substituting, where visible on the screen. Can you see it? So, A, formula for work, W equals H1 minus H2 plus H3 minus H4. Next, by substituting it, W equals 3910.9 minus 2843.041 plus 3699.4 minus 2462.81. And in calculating it, the answer is 2304.449 kilojoule per kilogram. Okay, next. WN or net cycle work equals 2304.449 minus WP. W of WP is 30.115. So when I calculate it, I get the answer 2274.294. Next, QA or heat supply equals H1 minus HB5 plus H3 minus H2. By substituting it, QA equals 3910.9 minus 168155 plus 3699.4 minus 2843.041, and next by calculating it, QA equals 4,599.104. Okay, for N equals WN over QA. Its value has been obtained, so WN value is 2274.294 while QA is 4,599,104, and by calculating it, N equals 49.45%. Next, B. Getting the value for H3, H4, so formula for that, W equals H1 minus H2 plus H3 minus H4. Since we get the value of H3 and H4, it will be substituting it. So W equals 3910.9 minus 2843.041 plus 4062.5 minus 2566.778, and calculating it, W equals 2563.58 kilojoule per kilogram. Next, N equals W minus WP over H1 H minus HB5 plus H3 minus H2. Formula for N, again formula, that's formula for N. Again, substituting it, N equals 2563.58 minus 155 over 3910.9 minus 168.155 plus 4062.5 minus 2843.041, and calculating it, N equals 51.5%. Our M, since M is given, M equals 3600 W over W, or work. Next, substituting it, W equals 3600 over 2563.38, and calculating it, M equals 1.4 kilogram per kilowatts hour. Okay, next, C. Getting the value for H3 and H4. The formula for that is W equals H1 minus H2 plus H3 minus H4. And then, substituting it, since the given value is already there, W equals 3910 minus 9 minus 2843 minus 041 plus 3051.6 minus 2560.7, and calculating it, W equals 1558.759 kg per kilogram. Next, Wn, or net cycle work, equals W minus Wp, and the answer for that is 1528.604. QA equals H1 minus HB5 plus H3 minus H2, and then substituting and calculating it, QA equals 3951 minus 304. Next, N equals WN over QA. So substituting it, N equals 1528.604 over 3951.304, and calculating it, N equals 38.68%. Last, M equal 3,600 over work or W. So W for work is 1558.759 and calculating it, M equals 2.3 kilogram per kilowatts hour. Okay, thank you.